Yeah. Good morning, good afternoon, or good evening, wherever you are in the world. Welcome to my presentation, and thanks for joining me today. My name is Aparna Konduri. I'm a senior software engineer at Microsoft. I've been at Microsoft for a year and a half. Prior to that, I worked for a few years at Amazon, and I also have many years of experience in the industry. I'm software engineer, yeah, build mostly backend engineer. And today I'm going to be talking about change the way we do DevOps for SQL products using modern scalable technologies. I chose this topic because I work on the SQL Server DevOps team, and we have built some really good practices to build and release SQL Server at a scale. I know I'm a software engineer, and many of the people here, the audience, are data engineers, are DBAs. And so I tailored my presentation to present one of the use cases that you're more familiar with. So that would be using the DevOps to handle database projects. How do we do use some of these existing practices that we software engineers are so used to doing, things like we use version control, and we go through the code review process, we build and release. So this is all part of the SDLC lifecycle, and we use DevOps. And as part of this presentation, I'm making an effort to see how, to show that DevOps can be used to handle even database projects. Why do we need modern scalable technologies? So we have all been in situations where we didn't use version control, and or we didn't check in the code into version control, and our code got wiped out, our scripts got deleted, our computer crashed, or the databases, they ran out of resources, and then there was no way to replicate the resources. So many things that go wrong, and the distributed architectures have always been our savior. And more and more investments are going into building scalable solutions. And so I'm going to talk about Git, which is the version control in Azure DevOps. And Microsoft owns GitHub now. And I will also walk you through the important functionality of Azure DevOps. Because there is no NDA, I cannot talk about the DevOps for SQL Server as such, but I can walk through the practices that we have internally through a demo application. So please feel free to interrupt if you have any questions. If the questions are not directly related to the presentation, I can take questions towards the end. So I have only one slide on Git because I have subsequent slides that builds on some of this knowledge. Many of you have already used Git, but if you have not, it's a distributed version control system. And so essentially, my code is versioned. Like I have a local repository and also a remote repository. So the way I start with Git is I have my own file system. So like I'm, say, a data engineer, I'm writing building my scripts locally. I add them, I stage them to the staging area. So staging area is where it's where I stage all my changes. Like say I'm releasing a feature, for the control plane, and say it can be logging. So everything that's related to logging, all the changes I made to logging, I would like to stage that and then commit those changes. So once they are committed, they are in the repo. And say tomorrow I change my mind and I don't like my own implementation, there is a way to fall back to a version that's from a day or two ago, or even back further. And as long as it's in the local repo, only I can see my changes, and they're not visible to any of my team members or others. So what I would do is I would push my changes to a remote repository. When the changes are pushed to the remote repository, then they're available for others. So they can view the changes. They can, again, there is versioning here. So the changes can all be merged as if I'm going to talk about the master branch, which is the central branch for all of the engineers to work together. So that's the master branch is the central branch in the Git repository, and we use, so I can have my branch Aparna where I'm working on my changes, and I can have a colleague whose name maybe John, and John is working on his own branch and making changes. So we all of our changes have to be merged into master, and master is when everything gets merged, and then we can build and release. So if I want any changes that were made by John to be merged into mine, I go through the reverse process. Don't want to spend too much time beyond this on Git, but this is a great book if you want to learn more about Git, the professional Git. It goes into all internal details. And then also there are resources on GitHub, you can play with. Now coming to the Azure DevOps. Like, why do we need a DevOps tool? Especially if you're looking at big organizations, whether it's banking or even Microsoft SQL Server, you can imagine thousands of engineers working on SQL Server deliverables, and so there are 50 to 100 teams working on different features. And now all of this code needs to be built and released to the external world. And so each team will have their own Azure board. Azure board is where you plan your work. So the planning can be done. It's different in different companies. Amazon, for example, follows the quarterly model, and Microsoft follows the semester model. And and then banks might have a yearly model. So you set up this Azure boards or the project plans, like what you want to accomplish and the milestones. And then once, so the project plans, they drive the work for the semester, and then Azure repos are where my source code repositories, like the Git repository store is inside my Azure repos feature. And then there is this Azure artifacts. So, software engineers, we live and breathe through artifacts. Essentially, it's a way to distribute my packages to other teams, or internally or externally. So you might have heard about NuGet feeds. So if you go to GitHub or NuGet.org, there are multiple feeds. So for example, Microsoft DLLs, like if you want to download any of those packages, you refer to the NuGet feed, and then you can download the DLLs and integrate, build and integrate these DLLs as part of your solution. Similarly, Maven is it's mostly used for NuGet is mostly .NET based. It's .NET based package manager, and Maven is used for JVM Java based applications. There are jar files for Spring, Hibernate. So there are Maven repositories. So internally, the way we use artifacts is we have all these teams. So if I have a base team which is building all these DLLs or libraries or packages that I want other teams to consume, so essentially I can also generate a NuGet for my packages and drop it into this artifact store. And then the other teams can then just consume from this artifact store and then go on with the development. That's it. So that's how we collaborate, between different projects. And then the Azure pipelines. So now we have code inside the repos. Now we have the NuGet integrations, and now the builds are, now we need to build this and deploy this. So this is where the Azure pipelines come into picture. And the Azure test plans. This is still a feature that we do not use much. The test plans, I have looked into it, and it's only currently used for manual testing at this point. Maybe there would be new features going further, and we would be able to use Azure test plans, but this is not very well used at this point. So yeah, we follow the sprint boards, and so we follow this methodology of epic, feature, project, backlog, item, and task. Epic is the 6 month what you want to deliver, and then the features are your milestones, and each feature can have again sub features. They are called project backlog items. And then under each sub feature, like for example, if logging was my feature, and then this, integrations like distributed logging can be one of this, the thread model can be one another. So the tasks for each of those would be under the product backlog item. So I already touched upon the Maven repositories CI/CD. Then we have this in the pipeline world, they have this classic versus YAML pipelines. Classic pipelines are essentially the drag and drop pipelines for builds, and YAML is script based. And before we go any further into ADO, these are primary concepts. There is an organization, project, and a repo. So this is the way to structure your artifacts, or how structure your files, or this is the high-level structure in ADO. So an organization is a group of related projects, and then so project is anything, all the everything that's related to a project can be in a project. So I'll just walk through an example to just make it easy. So say I'm a bank, and I'm a finance, so a bank, like let's say Key Bank or something like that. And then my finance division can be my organization. And under that, my project would be like the home loans, personal loans, the financial services. These are all can be different projects under the finance organization. And then the repo is like the databases, right? The home loan databases, and then the services, the cloud services, or any other services that are needed to, support this home loans feature. So like that would be in the repo. So again, it's a tree hierarchy. Organization is your top level, and project under, and then the project will have multiple repos under it. So how does this whole thing look, if I want to put everything together? So the work is driven through Azure boards. The engineer picks up the work from there. And then I'm showing Visual Studio here because this is what I use. But if you're used to using Azure Data Studio or some other tool, you could use that. Pick a tool that has an integration with Azure repos. That way, Azure DevOps. That way, it's much easier, seamless integration. So I code. I build my scripts. I write my code here. I check in my code, and then so now it's part of this Git repository, and it's in the remote repository, and it's stored in the Azure repos. And once the code is in the repo, then I build the code using the pipelines, and then I deploy it. So in the context of this presentation, I'm deploying the builds that are coming into the Azure SQL Server. And then you can also set up Azure monitors. So say my query is taking longer, or my database is running out of capacity, I can set up alerts on Azure and get notified. And if this is a pressing issue, and I need to work on it, again, I would create a work item to track my work and go through this cycle all over again. So any questions? Now I'm getting into the next part, which is the most important part, the demo part.
You don't have any that have come through yet, so you're good.
Okay, thank you. So yeah, because there was no NDA, and I essentially set this all up using my private account. I signed up for GitHub, created an organization project repo in Azure DevOps. Then I created a database from scratch. Again, I was tailoring the presentation to the audience. So I chose the AdventureWorks LT database. I went and downloaded the scripts. then I went through the, adding them to Azure DevOps and built and deployed it. So signed up, got an organization by default. So this is my GitHub account credentials, so usernames, I just use that. Then I went and created a project. And now my repo, which is where all my code is saved. So the repos are where my code is saved, and right now it's empty because I don't have any code. But it tells you how you can mount this repo. If you want to connect to this repo, so what the commands that you need to run. And so that was on the Azure DevOps side. So now that I have an empty repo set up, I come back to the Visual Studio, and then I connect to that repo that I just created. And I cloned the repo, and then I created a local workspace. So that means I'm setting myself up for any changes that need to go into Git. So I cloned the repo, and once I start adding my files, they become part of the staging area. And then once I commit, they become part of the local repo. And when I push it, they become part of the remote repository. So I created the database project in Visual Studio. The AdventureWorks LT database that I downloaded for some reason did not work out of the box. So I needed to make some tweaks to the scripts and then make it compile in Visual Studio. So just to give you an overview, so I opened one of the files and looked through the SQL scripts. I made fixes to the files. I believe one of the sequences was missing. Once I fixed it, it compiled. Then I staged the files and I committed the files. And then I pushed them. So now they are part of the repo, and you can now going back. So I hope you're clear now. I'm switching between Visual Studio and Azure DevOps. Visual Studio is my development environment where I'm building my scripts or code, and then Azure DevOps is where I'm actually my changes are getting reflected, and then I'm getting ready to build and release this from Azure DevOps. So you can see that earlier this repo was showing as empty. Now it's populated with data. And there are a couple of things I wanted to talk to you about. Some of this maybe you're already aware. Azure DevOps really has this cool feature of pull requests. So anyone who has worked on the software side, like I was a software engineer, they build and live through the code review process. So you cannot check in the code directly into master. Master is your central branch, and work from many engineers get merged into master, and you don't want to pollute that. So normally what, like I mentioned earlier, you would create your own user branch, and then you push it to your own user remote branch, and then go through the pull request process. So to just give earlier, my code worked because I did not set up these branch policies. Because I said, oh, master, I can check in everything to master. So from Visual Studio, I push the code directly into master. But if I wanted this gating, like I want to gate my changes to master, so what I would do is I would actually set up these branch policies and then say that I would at least require one reviewer. And then the reviewer would go and look at my changes. And also I'm saying, check for linked work items. So these are the work items that are in the Azure board. So I want to make sure that I'm making progress towards the work in the ADO work item dashboard, ADO work items, and track the work through the PR process. So it's a way for, like, for example, management or leadership want to know how much progress has been made. So all of this helps to see, like, for this feature, these pull requests, or for this work item, all these pull requests were sent out, and then this code got merged. So it's a way to tie everything together. So and also there is this cool feature of build validation. So what it does is before the code is actually merged, it's not just someone else reviewing your code. It also runs a delta. So it takes the master and then puts the it's before applying the changes directly to master, what it does is it actually takes a copy of master and place your changes on top of that master. And if that a branch was created with that and a build was done, if there are any build failures, then the pull request is right away rejected, because you're trying to push a code, push some code which would essentially break the master. So this build validation is heavily used by us. And so we have build validation, and we also have multiple reviewers for each of our code reviews that we send out, or the pull requests that we send out. To just walk you through the pull request experience, again, I created a branch now. Earlier, if you look at my previous slides, I was just playing with the master directly. So I created a branch. So ideally, the change that I'm trying to push here is the unit testing. So in addition to just downloaded the AdventureWorks LT database, I also created a unit test project to test the scripts. So I chose a function. So the way I went about it was I created the SQL Server Object. Created the unit test project and connected to the database against which this test need to be run. So essentially, instead of creating all this mock data in the database, you could play with your test database with some data in it, and then write a unit test to point to that database, and then have set up some test cases. So this is similar to your C# unit tests, or C# or JUnit tests, etc., where I would actually have some conditions in there. Oh, when I run this query, I expect to see an empty result set, or when I run this, I will expect to see. So I'm actually setting up what I expect to see when I run this test. And then, so now when these tests are set up and they are run, you can clearly validate that if things are working as expected, and you check in this piece. And this is a very good way to validate when the builds run, that it's not just compiling the code or compiling the scripts to make sure that the end package or end DAC pack file is generated, but also making sure that the results that you are seeing is what you expect to see. So unit testing is a very good big piece of the puzzle. So we write a lot of unit tests to validate our code. Otherwise, the code doesn't even pass the check-in process. In many teams, there is a minimum bar for the unit test coverage. So yeah, it's a good practice to have. Yeah, now again, I checked in. I checked in all my changes. When I built the project, I also got so many extra files, but I don't want to check in all this generated, the end DLLs or generated code. So I leave them as is, and then only check in the important files, like only the files that need to be under version control. So now I checked in the code, and now I moved from Visual Studio back to the Azure DevOps. And now I see this, that my code is checked in. And then now I have this, instead of the code is not just getting into master. So it gives me this option, like create a pull request. And so this is, so it's essentially, this is pull request is nothing but a code review process. It gives you a diff of what changed. And so people, can clearly see, the reviewers can clearly see what is changed, and then review it in detail, and then approve it. Once the changes are approved, and then the builds are successful in the pull request, then the code gets merged into master. So now the code is all in the master, and now I'm going to demonstrate how to build and deploy this. I already talked about classic and YAML pipelines. If you have never used pipelines before, start with the classic pipelines, because it's an easy drag and drop experience. And even though ADO does not, going forward, ADO's recommendation is to use YAML pipelines. So what you can do is start with classic, and then classic pipelines have this export option on them, generate the export to YAML. So you can use the export to YAML option and still get the YAML script out of it. and then change it if you want to enhance it. So now, yeah, I'm going and creating my pipeline. I'm saying that my code is in Git. And then, yeah, the branch that I would use for builds is master. And I created an empty job. And so it chooses an agent. So agent is the machine on which this pipeline runs. It can be an agent pool. You can imagine like for building bigger projects like SQL Server, we need thousands of machines, and then we maintain pools yeah, maintain pools. So this is one of the hosted agents. Essentially, that's the advantage of having a solution like Azure DevOps. You don't need to provision the servers. You don't need to maintain these Git repos. All of this, right? It's an integrated solution where you can have the code in one plan, have the code, build it, and then also, you know, and then test it, build, test, and deploy. You know, you can do everything, and it's an integrated solution. Okay. So now my code, I pointed my code to the branch where I want to get the code from, and I chose MS Build for building this project. And I looked up this online, this option for building database projects that can speed up the builds. Yeah, then this is an important link that you might want to be familiar with when you're working with the pipelines, because the pipelines have some existing predefined variables. Like, for example, like what's the build directory? Say you want to write a script to just copy a particular file from the build directory to some other directory. All of this, that script would, all of this is possible if you know how to get that grab that directory from the agent machine, because this is not your local machine where you can say cd this directory and grab the code from there. Here, this is agent, and agent has multiple directories, one for source directory, one for build directory, etc. Right? So I highly recommend for you to look at this link to get familiar with the different predefined variables. And once once you are familiar, then you can write scripts in between. So here, you know, I dragged and dropped multiple tasks here. I'm building the solution and generating the artifacts, the DACPAC files. And then I am then using an Azure PowerShell script to use this DACPAC file and then deploy to Azure SQL Server. And so this is a deployment, and this script is essentially for creating all the Azure resources. This inline script task I created, once I know my Azure subscription, this script will go and create the resource group, the servers, and then an empty database. So right now I am using a generated UUID. So to just speak in regular terms, so this pipeline whenever it runs, it creates a new database. It creates all these Azure resources, you know, by just changing an ID number and changing a number at the end. So that's how I'm like generating resources. But if you have one database and you want to keep updates to the database, you have to be careful about the DACPAC file. I'll talk about it in a minute. So this is how far, to just recap what I'll have done so far. I built the project and generated the DACPAC file. I created, so this is a good script. So it's an Azure PowerShell script for creating all the resources on Azure. And then I noticed that there is this sample database parameter. If I did not, so what it does is, irrespective of my database schema, if I have this parameter, it would automatically generate the database with the AdventureWorks LT database. And for my purposes, because I am using this database for the showing, for demoing this whole project, for demoing here. So I removed that sample parameter. So essentially, I just got an empty database and I applied my changes on top of that. Yeah, it did not go as smooth as I expected it to be. So I noticed there were some firewall issues. So I needed to open firewalls to be able to connect from the pipeline. And I also noticed that the target server that I was connecting to was incorrect. So I needed to go and change it to the Azure SQL Server. So I went back to Visual Studio. I changed my target platform to Azure SQL database because this is where I want to deploy the database. And yeah, again, I went through the changes, checked in my code, and now my changes are in master. Essentially, yeah, even then, I'm not showing the entire pull request thing because I'm the only one working on it. But ideally, yeah, you would, if you're ideally you would want to have one more person review your code before they get into before it gets into master. So now my pipeline is all running fine. It's succeeded, and now I log into Azure and I see, yeah, it create this. So this server got created, and this is my own database. And then I wanted to validate that the pipeline generally created was even correct. So what I did was I went into the query editor and ran some queries. I didn't add too much data, so that's why you're seeing no results, but I have validated through the unit test that it was what I wanted to, what I expected to see is what I was actually getting. So I validated the data. So now, so how do we use this feature? How do we, what would be the practical use cases for this project, right? If you had something like this. So you could create a test database. It's a test database. So each, if you have multiple data engineers, and then you have, you can, if you want to validate and then keep in mind that I hope that test databases, if they are small, like you, and it's good, right? It's you can each user can spin up their database, validate their changes, and then tear them down. So it's not like a database that you're going to hold on to for a long time. So you can have the pipeline run, whenever you want, add it at the end of the day, every day, and then generate a test database, make sure that it works. So you can have one static test database, or you can have multiple test databases, one for each user or each engineer or DBA. That's one of the use cases. So it's also easy going through the Visual Studio, using Azure DevOps, and then deploying the database to the Azure cloud. And say you have large databases, you need to be a little bit careful. Instead of one database project, create multiple database projects and make sure they are, they have different tables. For example, the DBA tables and customer tables can be two separate projects. The reason why I say this is because the end result of this project is actually a DAC pack file, right? The DAC pack file gets generated. And so the DAC pack, the way I have seen it and read, is it's actually a delta over an existing database. So if me and John were trying to play with the changes, and we have overlapping table changes, we might overwrite each other. So essentially, that is why I was saying that if we actually work on different projects, which touch different tables, then the DAC packs those are being played will not collide with each other, and the end database will be the same. So that's how you could structure if you're actually working with really large databases. And also you're speeding up the build using this, the MS build option, because this actually validates the schema right within the memory. So yeah, so again, a recap. The project is in Git. Use Azure, Visual Studio, and use the pipelines to build and deploy the database to the cloud. Validated the changes used in the query editor, It made a couple of recommendations for handling large projects and speeding up the builds. Internally we have custom solutions to speed up the builds. They're all they're scalable solutions that are internal, and cannot really talk about those, but feel free to plug in any external build solution that is scalable, and you can integrate that engine into Azure DevOps, and then get your builds running at scale. Anything any questions?
I'm just double checking to make sure I didn't miss anything. I don't see any.
So should I pass my share? And
oh well, let's just hang and see if anybody has, if any show up in here. That was a lot of information. I think for me, I'm just kind of still trying to process it. I don't work a ton in the DevOps space. So most of this was pretty new to me. I admit this is not, but I'm thinking that most of the people who attended are much more familiar with it. So I'm guessing it wasn't quite as much of an overload for them.
It's good to always learn something new, right?
Oh, it is. It is.
Yeah.
So what do you think is one of the biggest challenges that folks tend to have with DevOps?
I think that's a very broad question, right?
It is.
It's like the code coordination, and then I think making sure like whatever code coordination, and then like you have backups, and then the ability to restore if something goes down, and then like scalability is really big. Making sure that your builds can scale, like your repos can scale. Say I have SQL Server is a really old product. We have really large repos, and then other big teams, they have larger repos as well. Like we need to make sure that as we check in more and more code, that the performance does not go down. So how do we keep up with the load and also keep the performance? How do we prevent any crashes? We want to make sure that the builds are still within the SLAs that are imposed. And then things can, even in spite of all of this, things would still go wrong. And then how do you quickly recover from them? Like, how do you get those timely notifications? You can use Azure notifications. I highly recommend using that. It creates ICMs. So it creates incidents, and then you can get timely notifications if something goes wrong. And you can imagine for some of the high customer facing products, they have 24/7 on calls, like where we take rotations, and then like making sure that the builds are not blocked, and then the deployments are going fine, and then they are still secure, things are secure, and making sure that there are no loopholes, and for secure attacks, things like that. So it's always prepared. The DevOps products, they're preparing and delivering at scale. And in spite of all of this, things go wrong. And as I mentioned, like the agility to recover from all of this, that's that's the big challenge for us.
Has that been my next question was going to be, what was the for you personally, like as an engineer, what is one of the biggest challenges you've faced in working on this for the past year at Microsoft?
Personally, for me, I did not work in DevOps until I joined Microsoft. So I was working mostly in the cloud services. I worked on the AWS, Azure, Amazon Web Services, and then building cloud services there. So I'm very familiar with the cloud products. So for me, when I joined this team, like the DevOps, the build and release, this is like phenomenal how we take things for granted. Like even at Amazon, there are really highly scalable build and deployment solutions, and you just take them for granted, right? So you check in your code, and then there is this really cool pipeline that's building and deploying everywhere. And occasionally you would check and babysit if things went, if things go wrong, then yeah, maybe you could occasionally check and maybe re-kick off the deployment. But many times it's like I take the DevOps for granted. As in, that's what I did. Until I joined this team, then for me, it's like, whoa, a lot goes into making this happen. Like making sure there is enough capacity to build and test, and making sure that when you have a very big repo where thousands of engineers are working, like how do you make sure that it's still scaling well? It is still there are no merge conflicts, and the code is still moving. So it's very complex. It's not as simple as like as an engineer where I'm just thinking about my product and then checking in my changes. I'm dealing with like this 50 to 100 teams, and then like they're all raising issues. My build is not working, my code is not merging. So it's like it's very busy, and but I like the challenge. It's stretching me. I'm really excited about this being here and the opportunity that it comes with. Yeah.